Long before I joined Rebellion to work on the titles that you can see on the screen right now, and before I became a senior environment artist, I used to work in a smaller indie studio where I was a 3D generalist. Over there, I had the opportunity to work on this game that you're seeing right now, and I have a little story to share from it that relates to the topic and the showcase of today's video. When Hyper Brawl Tournament was getting released from Apple Arcade onto PlayStation 4, it struggled with a big issue. When we were creating builds and submitting them to PlayStation for them to approve so the game can go on the PlayStation 4 store, we were consistently not hitting 30 FPS. That meant that we were failing our submission. In order to rectify that, one of the programmers that I worked with created a bunch of tools that would open different levels in the game and graph out the FPS, or more like the MS of the scene. I kicked in and started trying to optimize the different parts of the game, trying to win us a few MS so we could actually turn on some special effects like bloom and other post-processing, while also not failing our PlayStation submission build. I'm sharing this memory from my career because what I ended up tweaking the most back then when I did a successful batch optimization were VFX. I created the VFX for a video tutorial that you can find. So yeah, if you want this type of like gateway portal, just make sure to watch the videos. And after I wrapped up some of the parts where I showed you how to create the Niagara particle effects, I went back and I actually optimized stuff and I fixed my performance issue. To be more specific with what I'm talking about, here, if we go Stat FPS, we see that while I'm recording with OBS, I have 50 FPS. And by the way, just a little disclaimer that this is the engine running. So this FPS and MS is not actually a reflection of what the player would be experiencing. What the player will experience can be tested in a standalone build. I will not be creating builds of this right now. The margin of error will be like, it will fluctuate the difference between the editor and the build, but we can nonetheless work through it and I can show you the mistakes that I made in the VFX and how I fixed them in order to gain my FPS back without having to do builds. So the first command that I put in there was stat FPS, and it gave me up in the corner, and I hit it now, the FPS and the MS. The other one that I really like is stat unit, because that actually is much more important. It gives me this detailed breakdown, as you can see on the screen right now. You can see my memory usage, my draws, my game time and my frame time in MS, and the input, the draws and the primitives. Some of these, they didn't used to be showcased just a few versions ago, but Epic have updated them and it's pretty cool. As I said already, you can see that I'm consistently reaching 60 FPS, but before I fixed my VFX, I was actually hovering around 15 or 20. I don't really like measuring this in FPS. It's actually more precise to do it in MS, but I assume that FPS kind of like sounds better to people that are not nearly as much into tech art. It's more understandable to gamers as well, so that's why I'm referring to the FPS right now. When I realized that there's something wrong with my scene, the first thing to do was I went into Stat, and when I typed Stat SceneRendering, I get this profiling tool. There are again more precise ways to profile, I'll show you in a few moments, but when I went in here, I could see that everything is fine now because you're seeing the result of my optimization. But bear in mind these stats, look at the amount of ray tracing dynamic primitives. They're hovering at around 168,000. Look at the MS it takes to do the render view family. It takes 10 MS. In neat views is hovering at 1.2, and the other numbers are like relatively small numbers nearing 1 MS. I'll explain what some of these do in a moment. What I'll do now is I'll go back in time. I open my GitHub and you can see here I actually described it that I did changes and gained back 34 MS. Anyway, this commit, this change and this fix, I will revert and I'll essentially get this scene back into a broken stage. Okay, so let's do that together. Okay, we are back and we are back in time. As I mentioned, I reverted all of the fixes that I had done related to the VFX. I have opened the scene and you can actually already see that there is a lot of struggle. We are getting ray tracing geometry requested memory over budget, which was my initial warning that made me realize that something is wrong, as if it weren't obvious by the low FPS. I mean, by low FPS, look at this stat FPS. I am literally at 15 FPS. I'm 60 ms. If before I were at around 20, now I'm at 60 ms. So yeah, incredibly bad. And now let's do stat unit like we did before. You can also see a bit more detailed breakdown here, and you can see that the primitives and the draws are off the roof compared to what we were looking at before. I'll try to do some video editing, by the way, and superposition this with this low performance versus before with high performance. You can hopefully see the change. And then I mentioned that I did stat scene rendering, which is my imperfect way of doing some profiling here. By imperfect, I mean some parts here are not displayed really well. I'll show you where to look in order to do a better detailed breakdown in a moment. But anyway, let's compare this scene rendering now back in time to the scene rendering from the future where I did the cleanup. You can immediately see that the render view family is off the roof. The ray tracing dynamic build primitives are off the roof as well. The finished gather ray tracing instances is incredibly high as well. I could see this as an issue, so the next step in the investigation was to understand where the problem comes from. I actually immediately remembered some settings in my Niagara VFX related to these Q vortices that when I put those settings on, I questioned myself immediately and I was like, I'm not too sure if what I'm tweaking here is right, but I'll leave it like this for the moment. That is why when I'm looking at a part of the screen and it's like incredibly laggy, I put on my stat scene rendering here and I start to analyze stuff, and I can a bit better pinpoint what the issue is. But if I wanted to do a bit more visualized and more detailed profiling, instead of doing the stat scene rendering, I would say ProfileGPU. What this did is it took a snapshot of the screen at the moment of time, and then the data of the different parts and the time it took to render different parts, it plotted in a chart. The best way for me to visualize this frame that I took a snapshot of just a moment ago is I click here and I go from hierarchical to flat. And essentially in my buffer pool copy OPS, you can see different color for the different parts of the rendering, and they are showcased. The longer and the bigger the chunk is, the more MS it took. So I immediately know that this build part here actually took a lot of time. You can see it in MS around here, right? So I kind of get a clue from here that ray tracing dynamic geometry is taking a long time. And that makes me realize that there must be some non-static geometry in here that is causing this build issue. I have the tower, and every geometry related to the tower I've marked as static. It's not even nanite. So I kind of like already know that it shouldn't be related to that. And in the scene, there are just particles. So I'm starting to get a picture in my head here that perhaps it is the particles that are the culprit. We can see that the sky atmosphere is taking a while, and the temporal super resolution is taking a while as well. The temporal super resolution is fine. It's doing it this way because I'm essentially rendering on higher than 4K. My monitor is 4K. You can see that I am rendering at a render scale of 132. I've done that so when you're seeing the video, things appear a bit more sharp. This is just like preference. I can change the screen percentage rendering to put it back to 100, but it doesn't matter. Like, we can already guess that it's not the culprit for issues. Sorry, I lost my stuff there. Let's put it back on screen. So anyway, we know that it's to build as I said, and then look at all of these little chunks here. I want to see what they are, and when I hover over each, I'm seeing that it all has to do with Niagara render ribbons, gen vertices reduction phase, and so on. And it's not even one long line like this, but you can see that there's just a lot of them, and they all have to do with ribbons. So I'm thinking that perhaps there's something wrong in my ribbons. I already know that these particles here have ribbons because I made them so. And perhaps not only is it showcasing here as these like tiny chunks, but I'm taking an educated guess and I'm saying that perhaps it then causes an issue here. So I will close this and I will go into my particle effect. And now this part of the video is me showcasing you how to fix your particles and gain back performance with the caveat that is if you're using ribbons. So I made a bunch of mistakes in the creation of all of this, and I'll show you how I fixed my mistakes. I'm not providing a one fit-it-all solution to fixing every Niagara VFX there is out there. I was just hoping that you will benefit from seeing how I profiled and fixed my specific issue in this case. So I have my spiral ribbons here, and I know that I'm using a ribbon renderer. And what I remember when I was creating this was that I really wondered about width segmentation count, and I actually bumped that up to 16, which was the max, because I thought, heck it, why not? I want these ribbons to be smooth as smooth as it can. But I remember that when I was putting this number up, I already was seeing that it doesn't make them much smoother here in this preview, if you're saying. So let me showcase to you. I'm at 16 really high. So put it to 4, the ribbon looks the same. Put it to 1, the ribbon again looks the same. If I change my view here to gray wireframe, it gives me these red lines, wireframes for the ribbons and the particles. My particles turn red because they're just cards. And if I change the width segmentation count back to this 16 that I had, you can start to see, no, you actually don't see it really well. So let's go wireframe. There we go. You can start to see these lines really dense. Let's put it back to 1. And this now looks a bit more manageable. 16. You can see how it actually makes it adds loops along. It doesn't add them with the length of the ribbon. It adds them on the width, and that doesn't actually change my visual at all, but it increases the poly count. Okay, so yeah, essentially I had made this mistake of putting this to 16. So I clicked on the ribbon, render with segmentation. It was to 16. So we lower that and we save. And then the other thing that I'm thinking is that the spawn rate doesn't need to be this high. I'm perhaps spawning too many ribbons over one another, and then that's kind of pointless. So let's try it with like 40. So yeah, I can already see that the effect slightly changed. So maybe I don't want that. Let's go back to 100. But now I'm seeing that from 100 and from 250, the difference isn't actually nearly as staggering. Can you see it? But let's be devil's advocate and let's say like, we really want next gen visuals here or whatever. We want to be really rich. So let's go to 150. From 150 to my previous 150, not that much of a difference, you know. And with less of these ribbons, it will definitely be more optimized. So yeah, I changed the spawn rate to 150 and I changed the ribbon with segmentation count back to 1 from the insanity, the big mistake that I had done of 16. We save and we close that. And we can already see that we're going into yellow, like we are regaining some of our FPS back. That is mainly because I wasn't intelligent in my setup of this, and instead of using one Niagara system and recoloring it once I place it in the world, I've created multiple ones. So I need to go and do the same tweak for a few more. And with that, we are at 50 FPS. If I weren't recording, we'll probably be back even at 60. So you can see that the primitives number is down. If I do stat SceneRendering, you can see that ray trace dynamic build primitives is actually down to 230K. We were, if I remember correctly, back at 4 million before this. I'll go video editing magic of like overlaying the previous and you can compare. So let's remove that. Let's invoke ProfileGPU for a single frame on the scene right now. There we go. And go to flat. And let's take a look here. See, if you remember, this build was taking 6 ms before, now it's down to 1. And all of these tiny cuts of ribbons that were here, and we were kind of like not seeing them really well before. They're still here, but like now they're a bit smaller as well. And just like that, now I can actually look around and I'm seeing good FPS as well. So I hope this was educational, but in essence, the overarching lesson here was that I made a very specific mistake, and I went back and I fixed my mistake in order to regain my FPS. I don't know if you have that specific mistake in your project as well, but I hope that me showcasing this tooling and this tweak in my ribbon renderer might be useful to you. And the next logical thing to keep in mind is that if here I just changed the width segmentation and lowered my geometry count and then my dynamic build related to my performance and everything, then you bet that a lot of these settings, not just the spawn rate, can, if used incorrectly or in a silly way, also change your performance. You also need to be mindful whether you're like using your GPU on the CPU. Excuse me. You also need to be mindful whether you're using your particle effects on the GPU or on the CPU. Essentially, make sure to double check your settings and always optimize your VFX. Thank you very much for watching. I hope this was useful. And I go from hierarchical to flat. And essentially in my buffer pool call